Hello, this is a recorded lecture for Chapter 11, Advanced Analytics in Healthcare, and this is under the HSC 400 Healthcare Analytics class. Now, analytic systems have the potential to provide healthcare organizational leaders with lots of information, and they can be extremely helpful in providing direction, if you will, for the organization. Healthcare leaders must now leverage the growing volumes of data to help gain insight and have some predictability of their future performance and resource demands. So this is where we get to the point where we have what's called predictive analytics. Analytics allows healthcare leaders to better understand the intended and sometimes unintended results of a QI or process improvement project. Now, an overview of advanced analytics is that healthcare organizations are at different stages in their use of what we call predictive analytics or other advanced analytics. And most have not completed the full transition. They are somewhere in the middle and probably more likely in the beginning. Advanced analytics is composed of a collection of methods and techniques used in concert together to create a predictive value or predictive indication of something's going to happen in the future. So advanced analytics is actually considered a branch of artificial intelligence. And it's built on the fundamentals of computer science, computer engineering, and statistics. So we start to develop an expectation for what's going to happen out there and sort of plan for that. Improving healthcare HCO quality and performance is really a long-term endeavor. It requires information insight. It has to leverage our business intelligence systems, helps to focus on the healthcare organization quality improvement and process improvement through deep analysis, helps determine the best opportunities for improvement, and with point of care, it can directly support decision making about patient care. Now, point of care is we talked about earlier in this semester, but point of care is where, for instance, we do a blood test to check for the blood sugar on somebody not in the lab, and that machine will we draw the blood, we run it really, really quickly through this little machine, and the machine then transmits the information through a wireless system to the electronic medical record. So point of care, we start to make better and faster and more timely decisions based on our understanding of advanced analytics. Now, predictive analysis, though clearly an important resource for improving the quality of patient care, within the healthcare organization, the transformation is often not really well understood. It helps analyze past events and information to prevent a recurrence of negative events. So it's used to look at what's happened and to stop the things, the negative outcomes from that. And it can use data mining as a major tool. It employs sophisticated mathematical and statistical approaches to analyze volumes of data, and is described as the analysis of often large observational data sets to find suspected relationships and summarize data in such a way to be understandable and useful. So the idea of data mining is we're able to drill down into what we're doing and start to look at relationships that may be subtle. For instance, we may find that the length of stay in the emergency room is all related to 2 or 3 other events that have nothing to do with the emergency room. Access to radiology, getting x-rays done, turnaround for lab tests, getting that done, turnaround for beds that are available in the hospital, getting that corrected. All those may be a cumulative, aggregative process that create that length of stay that's longer than usual. Now, applications of advanced analytics include clinical decision support, and that helps to provide evidence to support decision making by clinicians, such as it provides real-time point-of-care information. We know that the person's blood sugar is whatever it is, 93, and we don't have to wait for the lab to give it to us. It suggests possible diagnosis given ambiguous symptoms or incomplete history. There are a lot of little algorithmic sites on internet now, WebMD I think is one, where you can put in your symptoms. It'll kind of tell you what to think about for diseases. That's not quite that simple, but it is helpful. And it predicts likely patient outcomes given the patient's past history. So it can start to look at what are called comorbidities, where if a patient has more than one major disease and how they interact and what that prognosis is going to be. Now, it also helps with population health management. It determines the most effective interventions, prevention practices for high-risk patients to prevent future adverse effects, so it gives us that ability. Administration and planning It provides the ability to be predictive of potential future events. For instance, it can identify the resource requirements such as staff, supplies, beds, space, and other resources. If we make a change or our seasonal variation from January to June or whatever that is, so we can staff accordingly and have resources available accordingly. It's been used a lot in fraud prevention. It uses algorithms to detect patterns of past data consistent with likely fraudulent behavior. And it applies that knowledge in real time. It identifies the flags and suspect claim transactions and other suspicious activities before any funds are dispersed. Now CMS, the Centers for Medicaid and Medicare, use this on all the benefits they pay out. They really check that out, and they save several $million based on that. Now, text mining is one of the techniques or applications of that advanced analytic methodology we talked to. Now, EMRs, which are essentially data stored in a structured, numerical, historical, and codified format, are far more easily analyzed than all those manual things we used to do in years past. When you used to do mining or used to look for information in a paper record, you have to hire these people to go through and pull out information and track it. And there was a human error factor and lots of other things. You had to write it down on something, and they'd put it in a computer, and then we take the computer information. It was really, really difficult. Now, text-based data is usually unstructured and requires these sophisticated algorithms, which gives us that text mining we talk about. Now, enablers of predictive analytics in healthcare are methods. Statistical models and algorithms are used for predictive analytics, are data. The continued expansion of the electronic medical record helps to increase the quantity of data. The sheer quantity is excessive, and so it helps to filter through that, to sort of space through that, and come up with some conclusions. If you had to do that in a manual way, it would be just really horrible. And the truth is, before electronic medical records, we didn't do it very well. Software. Predictive analytics software is becoming more and more available, easier to use, cheaper than it was before, and so the software is becoming far more sophisticated, which means easier for the user. When you look at enablers of predictive analytics in healthcare, the models we talked about, predictive analytics is really a family or collection of methods developed from statistics, computer engineering, computer science. We said that earlier. And the methods are more accessible to people who may not have a degree in statistics, so these methods are really making things better and more accessible. Once mostly statistical in format, this area now includes artificial neural networks and decision trees, so you can put in a what-if question and get a predictive answer. We look at enablers of predictive analytics in healthcare. We look at data. The EMR and other electronic data collection systems are created a ready and voluminous source of data. And before EMR's data mining, like I said, was a manual process. It took hundreds and hundreds of man-hours, thousands of man-hours. And now the problem is sifting through the sheer quantity of information. Before it was hard to get, and now it's like we have more than we could ever use, and we have to sift through and sort of find trends. We look at enablers of predictive analytics in healthcare. We look at systems. Historically, analytics software is only available and utilized by statisticians and researchers. It's very complex. SPSS is one of them. It's just really difficult. Because analytics is emerging and becoming a rapid growing market, more and more software alternatives are becoming available. So easier to use software. Now, examples of capabilities that now offer for analytics software include statistical models, and we have templates for the user, so we can customize those when we start out with a standard template, so we don't have to start it from scratch. We have plugins for use with popular spreadsheet software. Now, these are pretty limited in use, but they have abilities. The ability of what are called open source statistical and data mining tools. That means that they're very cheap. They're created by the government and they're available for public use at an almost nominal price. They provide powerful resources at a very low cost. And then specialized file and data management systems that support extremely data-intensive applications. These all are part of that, improving that. Now, when you start developing and testing advanced analytics, the healthcare organizations can invest significant resources into development and the business improvement in analytic solutions. But they assume that data analysis is simply a plug-and-play effort. People still think that. They still see it as magic. And magic is you snap your fingers and it sort of shows up. So you have to make sure your audience is informed. You have to educate your audience when you talk about analytics, advanced analytics. It's not magic. It takes some time and analysis. And I always, when I used to have bosses that would ask me for analysis, I would tell them, you know, I can give it to you fast, and I give it to you fast and expensive, or I give it to you a little slower and not as expensive. Which way you want to go? And they would say, I want it fast. Like I said, okay, I'm going to have to hire 3 more people over the next 2 weeks to have it done. And they say, well, what's going to cost? And I'd tell them, and they go, well, maybe we could do it over 3 weeks. I said, well, that's good because that way I can only use the people I have. I can just reprioritize the things they're doing. And so you have to really be able to inform them what's going on. And the trouble is that people that work in this kind of thing like to have it be magic. They don't want people to know, what they're doing. And so often they'll say, well, I'll take me a week, and then they get it in a day or 2 hours, and then they will send it in, and people think, oh, you did a great job, you got it faster than you said, and they always want to get it before, they want to show off, so to speak. But you need to be accurate so that people can create expectations of when they're going to get their information back. Analytics software usually requires personalization for every healthcare organization, and that's the God's truth. It is absolutely different by organization. Every organization has specialized problems, issues, history, and that helps you to redevelop that. Now, there are two main types of models we talk about advanced analytics. There's classification and regression. And classification is an algorithm that attempts to place objects or groups. Hold on. I'm sorry, that tends to place objects or groups based on attributes and relationships. So variables are usually yes, no, or the Likert scale from 1 to 5, or other discrete data. And the prediction is based on the algorithm predicting an unknown value based on a continuous value function. That means that if we have 25 no's and 1 yes, we can predict that in the future we'll probably have 25 no's and 1 yes or something close to that. So it helps to do that. Regression is something different. It's a prediction model for data consisting of continuous or numeric variables like age, weight, or length of stay, or those kind of things. We do a regression analysis. So those are the two main models we use in advanced analytics. Now, there are several widespread frameworks that aid in the data mining and advanced analytic process, and the ones you want to get have what are called CRISP/DM, and they're a cross-industry standard process for data mining. And it helps to transfer information from one area to the other. So this is a standardized way of looking at it. It helps ensure the successful adoption of predictive analytics because it creates a standardization. So if you have one piece of software, another piece of software, they can talk back and forth, or at least you can read files back and forth. Now, the analytics modeling process overview follows like this. You need to determine the requirements to HCO. You need to understand, gather, and prepare the data. You need to house and implement an appropriate model. You need to evaluate the performance of the model, and then you deploy the solution. Now, these are the steps that are talked about here. And that's really important. Those 5 steps are important to follow, and it's really important that we start with baseline information here, determine the requirements, and then look at the baseline information. Where are we? When you go on a trip, you know where you start from. If you do it, if you try to do that in statistics without knowing where you start from, you have no idea how far you've traveled. So it's important that you're able to collect that information appropriately. Now, is a predictive solution necessary? If one is not necessary, then don't bother wasting time and resources. Decide a true need-to-know versus nice-to-have. So determine the value that the predictive solution would have to the patient, the providers, and find the organization as a whole. And you can create a separate research or operational requirement. So you have to decide you have to prioritize. How will a predictive solution be used? If predictive analytics is an appropriate approach to solving a clinical or other issue, the next question is, how will it be used? For example, is the solution required at the point of care in real time to assist in clinical decision making, or is it for administrative or planning purposes or whatever? Is the predictive solution feasible or possible? I'd like to build the Empire State Building one day. Can it be done? Well, no. So the next consideration is whether your solution is really going to be useful. Is it necessary to require data and algorithm processes are available in real time? Can you develop more flexibility? Can you alter the solution? Is that going to be helpful? So that's kind of an important step. Now, to understand and prepare data, you have the steps necessary for doing that include selecting available instances. So you selection of appropriate sample of records that contain the data pertaining to the problem or orientation. Build your baseline. Identify outliers. If you remove clear outliers from the data sample, that's important because people run to outliers. It's really interesting. If you have something that goes out of whack and something happens, which it needs 40 different elements to come together to make it happen again, it's probably not worth the darn to worry about it unless it's really critical. For instance, getting hit on the head by a meteorite. You could get hit on the head by a meteorite every time you walk out the front door, but most people don't look up for them. because the chances are so infinitesimally small that it's not even worth having that conversation. So you need to make sure that you throw out outliers. Dealing with sparse features, that means incorporating measures to accommodate missing data in important fields so that the model has a complete set of data as possible with which to work. And then converting data into a format that can be used within the algorithm. So these are the steps that you have to do for analyzing and preparing that data as you move forward. Now, when you evaluate the model's performance, because of the complexity of developing a model, it's important to test it thoroughly before you deploy it. Sometimes we get all excited about making a model, we deploy it as a piece of crap, and we have fix-its that go on for weeks. And so the people that are trying to use it are pretty disheartened by the time we actually have a usable model. Testing a model involves determining the predictive capability of a model on an independent set of data that has known results. So we run it on a set of data where we know what the answer should be, and we see if we get that answer. This is kind of a control system. Now, the primary factor being evaluated for a predictive test is the output variable of the model. So we want to make sure that we're creating the right model for the right question. Deploy the solution. We deploy a predictive tool. It's important that as important a step is building and testing a model. How you deploy it, you don't just put it on the online or the HCO's hard drive and say, here it is. You have to deploy it. It's like marketing. You have to market the tool. The analogy I use is in 1984, people everywhere decided they needed a computer. They just wake up one morning and decided, I need a computer. What they did is there was marketing and there was all sorts of things going on. And said, you know, you're not a very good parent if you don't have a computer for your kids. It gives them access to lots of information. The internet is wonderful, yada yada. And so it goes on and how you could send information back and forth. So everybody went out and bought a computer. They didn't. Now people have more than one computer in their house. And repeated reevaluation of the deployed model is also an essential step, so that as the environment changes or as the patient demographics change or as the HCO changes, the tool transforms with it. That has to be built into the system. And that means having somebody critically look at each of the deployed models and saying, is this still viable, and what do we need to change, and how does that do that? So the decision-making, examples of decision-making that could be considered are determining the possible diagnosis of a patient, taking preventive action to prevent queues in the waiting room, and that means waiting lines in the waiting room, providing necessary care to prevent long stays in the ER and preventing unnecessary admissions. All those are kind of important things to do. Now, a good overview of predictive analysis is really as follows. Statistical learning is a branch of science that focuses on the development of algorithms for data mining, machine learning, and inference. That's the foundation of predictive analytics. Now, statistical learning is commonly used by industries where computers must learn from data and make inferences or predictions. Facebook is a great example of that. You start to show what you like in Facebook, and it'll start sending that stuff to you. Or if you start ordering stuff from Amazon, it'll start putting up little marketing things about things that are either related to or like what you tried to order. There are many different approaches and algorithms and models that together form the tool set of predictive analytics. And then it could be statistical modeling or machine modeling, both of which are applicable. Now, regression modeling is one of the most common statistical approaches for predictive outcomes. It's a conceptually simple method for investigating functional relationships among variables, but a lot of people don't understand it. It's used in statistical analysis to quantify the strength of a relationship between a dependent variable and one or more independent variables. Let me give you an example. In my dissertation, what I looked at is what kind of faculty use what kind of multi-modalities, different modalities to teach students. Did they use videos? Did they use email to communicate with them? Did they use texting? Did they use online labs? Those kind of things. And I compared all those different things that they could use with how old they were, their degree, how long they've been teaching, how long they taught in a certain class, all those things to see if there's any relationship. So I looked at the strength of those relationships between all those elements of how they could teach and what they were actually teaching. Now we separate those between what are called dependent and independent variables. And dependent variable is the observation or outcome of the interest. It's the output of the formula. In other words, I would say this person has a doctoral degree and they never use videos. So the dependent variable is the outcome is they never use it. The independent variable is the output to a formula, can be considered a cause of a change to the dependent variable. So if I'd have found that people who had a doctorate in their what they teach, and they always use videos, and people didn't have a doctorate didn't use videos, I could say, it seems that the doctoral people with doctorates use videos, and the others don't, and I could start to look and see why that happened. So that's the next step. Now, usually regression analysts work with several variables that are thought to correlate to or possibly even be predictive of a certain outcome and determine if a meaningful mathematical relationship actually exists between potential predictors and the outcome. You're really looking for relationships that can affect the outcome. It will, as a person gets older in education, are they less likely to stay up with technology? Well, you'd think yes. Truth is, not so much. Is that the older, more mature, older instructors or professors are pretty consistent with most of the other professors except for brand new ones, who tend to be right at technology based probably on age and understanding of the technology, whereas one ages and doesn't keep up with it, one becomes farther and farther away from what's new. It's used in healthcare to better understand how factors are related, regression modeling that is, in determining outcomes and to predict outcomes of patients depending on what factors are present in what quantities. This is a way of looking at diseases that patients have, looking at all the indicators and determining whether they potentially are going to die or not going to die, or they're going to have a bad outcome, or they may not survive surgery, or on and on. They can do all those things. Now, here's examples of type of regression. We can have linear, multiple, multivariate, logistic. Linear predicts a response in a single dependent variable based on a single independent variable. The type includes polynomial regressions called, where the relationship is modeled in the form of nth order polynomial of a single independent variable. Just means we're going to look and see how many times it happens. Multiple predicts a response in a single dependent variable from two or more independent variables. And multivariate variate predicts a response in two or more dependent variables from one or more independent variables. And finally, logistics predicts a categorical response in a dependent variable from one or more independent variables. Now, when you first hear dependent, independent, you kind of get lost, and you need to really have that in your brain when you start looking at that, and you start looking at statistics. That's where most people start to think. They start to hear wah, 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 and not the information. So these are just different examples of regression modeling that we use. Now, the benefits of using regression analysis: regression algorithms are accessible. Most software can perform regression modeling with ease. We can use spreadsheet software for simple modeling, and a well-understood model and a standard tool for QI methodologies is regression modeling. And it's the model that other predictive models are really compared to. Regression modeling is really the gold standard that other models will try to obtain or try to attain to. When we look at machine learning and what's called pattern recognition, machine learning pattern recognition systems are predictive approaches that are becoming increasingly used in healthcare throughout the United States. And these type of approaches are necessary when a predictive solution is required. So they look for patterns, and they look for repetition of patterns to say, okay, what's going on? And machine learning means that it will start to react to people and give them information the way they want. So machine learning is heavily based on mathematics, different than statistical approaches that demand more conservative and restrictive analysis strategies. This kind of learning that I said is used, like you'll see in Facebook. So how are these systems being used in healthcare? Helps to reduce incidents of healthcare fraud. It's improving disease surveillance, making sure that diseases are monitored the way they're supposed to. Detection of tumors and other anomalies on diagnostic images. And common types of machine learning models are like artificial neural networks or decision trees, or what are called support vector machines. So this is really AI. This is learning from responses from people and reacting to that and making the information more clear. So here's the examples of different types of machine learning. We have machine learning systems here. We have ANN, decision tree, and an SVM. And it shows you how they're applied across the board. I'll let you look at that. That's table 11.2 in your book. And so you can look at those and see the difference of how you would apply those and what characteristics they have. So in conclusion, predictive analytics in healthcare is still a relatively new field. Even though the software is being far more sophisticated, it's not being deployed as much in healthcare organizations. Mostly people think it's because you have leadership that thinks their gut reaction is they've used for years, and they trust that, and they're untrusting of data. It's because these tools for implementing predictive algorithms are far from being ready for use out of the box. You have to do some customization every time. HCL's best approach before purchasing a model is to test several models and run competitive evaluations of the algorithms, and that's really important. I have said that many times when I've talked about bringing in analytics or bringing in that kind of software, is let's look at all the models, let's let the people that use them go through each of the models and then rate them based on what they see. We'll ask them specific questions, and we'll apply that in our purchase. We'll look at the time it takes for them to complete a given process in each time and see which one is shorter. So if they like one but it takes 10 times longer than the other one, we may not think about that, and so have them rate them on a certain scale, and that really makes a difference. So that's really important, so you don't buy one and think, it's like buying a new car, and as soon as you drive out of the lot you go, wow, I really like that other car across on the other lot. You don't really want to do that. You want to buy something because you're going to have to live with it for probably 3 or 4 or 5 years to make it useful. Within 3 years, you'll probably have an upgrade of the model, or there'll be a better model out. But you want to be able to, you're going to have to use it for 2 or 3 years. So you have to decide who you're going to come to the dance with. And if you don't come to the dance with a very good person, then you're stuck with it for 3 years. Okay, so we've talked about all of this in predictive analytics, and we're completed this chapter. Thank you very much.